Welcome to Python Basics with EJD. In this video, having considered Python variable data types, where we looked at integers, floating point numbers, complex numbers, booleans, and strings, this video is dedicated to arithmetic operations in Python, which basically puts together operations relating to integers and floating point numbers. Okay. Of course, don't forget we are using Google Colab for this. So I'll navigate to Google Colab, and from there we'll move on to the seventh lesson as far as what we are doing. The playlist is concerned for Python basics. So arithmetic operations in Python, that's what our focus is on. I think I've clicked two things, but it's okay. I'll close one that is not use necessary. Okay, this can go. All right. So this is the video. This is the worksheet on arithmetic operations in Python. Okay. So we'll run through this. I think it's a bit, but let's see how fast we can run through all of this. Okay, so if you've done some math already, so most of the things will not be strange to you. Only few things will come across as new, and that's basically what I'm here to explain as clearly as possible to you. So basic operations, and when we talk about arithmetic operations in Python, the table below summarizes common arithmetic operations in Python. We have addition, which adds two numbers, and the sign is plus. So 3 plus 2 is 5. That's normal. We have subtraction, where subtract two numbers. So that's more like subtract one number from another. So this is the symbol is minus. So you have 5 minus 3, 2. You have multiplication, which multiplies two numbers, where you talk about multiplication of two numbers. And here in Python, it is asterisk. Okay, it's asterisk. So for asterisk 3, you have 12, right? So then you have division. So this is regular division where you have it divides and you have float results. So here you have one front slash. So if you have 10 divided by 4, that is 2.5. All right, that's 5 over 2, which is 2.5. But then we have floor division, which is sometimes known as integer division. So in this case, it divides and discards the remainder. So we just need the whole number part. We don't care about the rest. So in this case, you use double forward slash signs, right? So 10 double forward slash 4 gives 2 because 4 goes in 10 two times. You don't care about the remainder. All right. On the other hand, we have the modulus, or which you can call the modulus division. So in this case, you need just the remainder of the division. And the sign here is the percentage sign. So 10% 4 or 10 modulus 4, that means when 4 goes in 10, what do you have remaining? So the remainder you threw away here, now you have it here. So, 4 goes in 10 two times, and you have 2 remaining. So that remainder 2 is what you have in this case. And we are going to see its usefulness as we go on in this video. So then we have exponentiation, which requires the use of double asterisk. Single asterisk is multiplication. Double asterisk is exponentiation when you raise something to a power. So 2 star 3 is 2 raised to power 3. That is 2 times 2 times 2, which is 8. So those are general things we need to know. So next, we need to understand the idea of PEMDAS or BODMAS in some contexts. So in what precedence should you have operations when you have, if you're carrying out some operations, what should be the order? If you have many operations at the same time, how should you proceed? So that's talking about order of evaluation. Python follows standard mathematical precedence rules, also known as the PEMDAS. Is it more like the American thing, while BODMAS is maybe more like British, I'm not sure. But we have these PEMDAS and BODMAS, and I think in their core, they are basically the same, I think. So of course, if there is parentheses, you deal with it first. Then next you go to exponents, and then you deal with multiplication, division, floor division, and modulus from left to right. So they are the same level, but so which one comes from left? Whichever one you have at the left, you deal with it first. So if you have multiplication, division, and everything, so you deal with multiplication first, division, floor division, and modulus from left to right. And then finally, you have addition and subtraction also from left to right. So if subtraction comes first, you do it first. If addition comes first, you do it first from left and so on. So we have some examples to consider in this situation. Imagine that you have 5 plus 3 times 2 exponent 2. So how do you evaluate this? The example we have said it here. So first of all, deal with the exponent. Because there's no parenthesis, so deal with the exponent next. So 2 raised power 2, that's 4. So you have 5 plus 3 times 4. Okay. Next, you deal with multiplication. So only multiplication is here at the third level. So 3 times 4 is 12. So 5 plus 2, 12 is 17. So if you print the result of this now, you get 17 pretty easily, right? So that gives us 17. Great. So then you can use parentheses to make the order explicit and improve readability. So parentheses can really help you to know to group things better so you can take care of what you need to do. So in this case, now if you have parentheses, of course, you have to deal with the parentheses first. So in this case, the parentheses here takes precedence over this multiplication. Of course, we know exponentiation takes precedence, is the number one, right? So, but because of the brackets, now you already know 5 plus 3 should go first. So 5 here, so you have 5 plus 3, 8, 2 raised power 2, 4. So you can now multiply 8 times 4, 32, and then you get this result. So the parenthesis tells you, it automatically makes them have precedence over the other ones. Okay, so what about integer versus float arithmetic, right? Integer and floats come into arithmetic operations. So if both operands are integers, the result of operations like addition, subtraction, multiplication, and floor division and modular division is also integer. So if you have two integers, if you add them together, subtract them from themselves, multiply them, do their floor division or do their modular division, you're definitely going to get an integer. On the other hand, if either operand is a float, so if you have two numbers, one is float, I did an example in a previous video where I had 2 and 3.5. So 2 is integer, 3.5 is float. If you add them together, they automatically become float. So float is like float supersedes, right? So float, removes the integerness of if that English is usable. So if either operand is a float, the result is typically a float, except for floor division, which may still return a float, right? So let's see how that goes. Okay, so look at this now. Of course, we are used to this. So I put all this blank print in between so that we can space out the results. So 5 plus 2, of course, is 7 normal. 5.0 plus 2 will not be 7. It will be 7.0 because this is float. So integer plus integer gives integer. Then float plus integer will give you float. Then 7 divided by 2. Of course, integer and integer, it will give you integer. Then 7.0 floor division 2 will also give you 3.0 in float because 7.0 is float. Then 7 divided by 2 will always be float, right? Because that's the way the division goes. That's normal division. So if you run this now, you get all these results I just stated up there, right? So that's talking about integer versus float arithmetic. Now let's go ahead and talk about compound assignment operations. So we can have compound assignment operations. Here, Python allows shorthand assignment operations that modify and assign in one step. So it is in Python you can multiply and update the value automatically, like this. For instance, you have plus equal to, so it adds and assign. So if you have x plus equals 1, so it means that whatever the value of x is before, it adds 1 to it, and then it now takes on the new value. For instance, if x was 5, so 5 plus equals 1 means that you add 1 and then the new value of x will now be 6, basically. So the same goes for minus. Minus equal to that, you subtract and assign. That means if x was 5, right? So you subtract 2 from it, and the new value of x will now be 3. That's what this means. Then star equals to multiply and assign. So if x was 5, like I said, so the new value of x will now be 15 because 5 times 3, 15. So the new value of x will now be 15. Then you also have divide and assign also. So the same thing, divide and assign. So 5 divided by 4, that's 5 over 4, 1.25, I think. So the new value of x will be 1.25. Then you can also do floor division and assign. So 5 again. So 5 floor division of 2. Of course, the answer is 2 in that case. So it means that x is now going to be 2. Then modulus is equal to, that's modulus and assign. So 5 divided by 5. The remainder is 0, right? So it means that x will now be 0. Then exponentiate and assign, power and assign. So that 5 again, raised to power 2, that's 25. So the new value of x is now 25. That's what this whole thing actually means, right? So let's look at some practical examples of this. For instance, imagine that you have x is equal to 10. You had x was 10, and then what you are going to do now, you are now going to have x plus equals 5. That means that 10 plus 5 is 15, okay? So 10 plus 5 is 15. So that 50, so it means that the new value of x is 15. So if you print this x, the first one is going to be 15. And then, of course, I use this blank to separate the result there. But then remember, it's the same x. So the x has become 15 here. By the time you now take the x here and you now say x star equals to, that means the x, not the 10 and the 15, the latest value of x is now 15. So 15 times 2 now will give you 30. So if you run this now, you get 15 for the first one and 30 for the second one. Does that make sense? I believe it does. Okay. So imagine if we now come, I can even extend it and say something like x, okay, exponent equals, say, 2. So, the x before now is 30. So now we are now raising that 30 to power 2. So we're now printing the new value of x, okay? So we have the new value of x. Run that now. So you now have 900. So, okay, I can put a blank print here to separate all of that. Okay. So I run this now. So 10 becomes 15, 15 becomes 30 when you multiply by 2, and that 30 raised to power 2 now becomes 100. That is what all these compound assignment operators are about. Then, talking about arithmetic operations, right? We have an inbuilt Python module called math. So the math module now, it can do some things on its own. So Python's built-in math module provides access to more advanced arithmetic functions. So some common functions include things like square roots. But of course, before you can use it, you need to import it. So we import libraries in Python, as you're going to see later. So this is a built-in library, or call it module. So you import the module. So once you import the module, so from the module, you can do square root. So math does square root of 16. Of course, we give you 4. So if you run that, you get your 4. Then math.pow, that's power. So that's 2 raised to power 3 here. This is what it means, similar to 2 raised to power 3. So math.po 2, 3 means 2 star star 3. Run that and you get 8. Then math floor. So 3.7. So it removes the decimal part and gives you the whole number part. That is what this simply means. So if you run that, you get 3. Okay. Then here, math seal 3.7. So it means that to take it to the nearest whole number at the top. So that's 4. Then math fabs minus 7.5. I think it's absolute value here. Then factorial, math factorial 5, that's 120 right here. Then math log 100, that's 100 log 10. Log 100 base 10, that's what this is about. Log 100 base 10 is like 100 is 10 raised to power 2. So log 100 base 10 is like log 10 raised to power 2 base 10. So the 2 can come back. So you have 2 times log 10 base 10. Log 10 base 10 is 1. So the answer is supposed to be 2, as we have it right here. So you can see that math floor of it implies the largest integer that is less than x. Math seal of x is the smallest integer that is greater than x. The math fab is absolute value, which is always float. Okay, absolute value 7.5, which is always float. Okay, so let's talk about negative numbers. How do we deal with negative numbers? We have modulus with negatives can be tricky, right? So you have -7 modulus 3. Normally 3 goes in -7 2 times, and then you now have remainder of 1. But here, because Python always returns a non-negative remainder when the divisor is positive, so it will always remain. So -7. So 3 goes in -7. Now this is really tricky. So -7 modulo 3 is actually 2. And the reason is Python always returns a non-negative remainder when the divisor is positive. So, but why is it 2? That's the question that needs to be answered. Normally, if there was no negative, right? 3 goes in 7 2 times, and we have 1 remaining. And that 1 is what we should have. But here now we have 3 going in -7. So why do we have 2 as the result? Okay, that's a question I think I would need to look for answer to. I didn't think about that before now, but that's okay. So tell me in the comment section what you discover about this. This can be quite confusing. Okay, let's talk about large exponentiation. Python supports arbitrary precision integers, so large powers won't overflow for sure. So if you want to print 2 raised to the power 100, that's a huge number and it works very fine. So just run it and you get this big number you have here like this. So examples of arithmetic in action. Imagine you have x is 2.3 and you have y is minus 4.5, right? Let me just separate, not necessary, but just for more clarity. So print x plus y. So that's 2.3 minus 4.5. So it's going to give us some negative value. That's minus 2.2. What about x minus y? So those two values are still what we are looking at. Minus 2.3 and minus 4.5. That'll be 2.3 minus 4.5. That'll be 2.3 plus 4.5, which is 6.8. So we expect this to give us 6.8. Then when we come here, x multiplied by y, that's 2.3 times minus 4.5. That will give us some negative value because we're multiplying. That's minus 10.35. What about x divided by y? So x is smaller than y in magnitude, but we have a negative value. So we're going to have minus some decimal stuff because x is bigger. So minus 0.5111 like that. So we have another one. A is 15. B is 4, C is 6, D is minus 11. Watch out. So we now want to do floor division. A, floor division or integer division. B, that's 15 divided by 4. So 4 goes to 15 3 times. So the remainder, we don't care. So the answer is going to be 3. Then A, floor division C, that's 15 divided by 6. So 6 goes in 15 2 times. We don't care about the remainder, that is 3. So the answer is 2, right? Then we have A modulo B, 15 modulo B. So 4 goes in 15 3 times, so we have a remainder of 3. So that remainder of 3 is what we are going to have here. Then A modulo C, all right, A modulo C, all right. So A modulo C, now that means 15 divided by 6. So 6 goes in 15 2 times, we have a remainder of 3 again. So we have this. Then A star star B, A star star B, all right. That is 15 raised to power 4. That's going to be some big number. Okay. 15 raised to power 4. That's 50,625. Then the absolute value of D. Absolute value of D. D is minus 11. So the absolute value of D means we short up the minus. We don't care about the minus. All right. Then absolute value of C minus A. Okay. C minus A. That is 6 minus 15. That's minus 9. Absolute value of minus 9. That should give us 9 like this. Okay. Then, of course, we can also do direct divisions like this. 5 divided by 2, that is float. That is going to be, as you expect, this should be 2.5. Okay, 2.5. Then 5 floor division 2. 2 goes in 5 2 times. We don't care about the remainder. Then here we care only about the remainder. 2 goes in 5 2 times, and the remainder is 1. So if we run all this, we expect to get 2.5, 2, and 1 like that easily. So now, let's see what are some applications of integer and modulo divisions. Of course, don't forget integer division is the same thing as floor. It's also the same thing as floor division. Okay, for the sake of clarity. So, for integer now, we just care. Is it floor? Let me see again. Is it floor? We call that. It's a floor, right? Yeah, floor division. Yeah, integer. Because we just care about the number of times that thing goes, and we don't care about the remainder. That's why it's called floor or integer division. Okay. So imagine that you write a code. You want to convert minutes to hours and minutes. So they are given a number of 2,417 minutes, and you want to convert it to hours and minutes. So you can see both integer and modulo will work very well here. So the total minutes is 2417. In hours, we know 60 minutes make 1 hour. So total minutes now, you do the floor division by 60. So you need the whole time. The integer value of number of 60 you can get in 2417, and you don't care about the remainder. Then for the remaining minutes now, you now do modulo division here. So you do 60 goes in 2417. Take away the whole, whatever remains is what we now need. So with this now, we can then get the, okay, we can even print, let's print each one. So let's say print hours, okay, separately. Then I can use a blank print in between. Then I want to print minutes, print minutes. It's giving me the suggestion already. Then I do a blank print in between to separate the answers. Then I can now do an overall one and I'll say uh total minutes. That's so this you're also using F string down the printing we learned in a previous video. So this is also using F print. So total minutes, which is 240, so 247 minutes is the same as whatever hours and whatever minutes we get from here. So just run that to one blow, you get your result. So if you put 2417 here, of course, 60 goes in 2,440 times, 17 is remaining. So this number of hours is 40 hours, then 17 minutes remaining. So 247 minutes, based on this now, is the same as 40 hours and 17 minutes. So if you don't want to just type a static number, maybe you just want to prompt your code to ask for a value at every point in time, you can also do that. I think we did something like this in a previous video where you can prompt for inputs from the user. So, and this is where this inputs becomes pretty useful. So now we want to wrap seconds to stay with 0 to 50 and 59. So it's more like you are given a number of seconds and you want to make it minutes and seconds, basically. So what do? Total seconds now. These are variable name total seconds. Then you need integer inputs. So you need integer, right? And you want the user to supply you the value. So type in number of seconds. So this input will prompt it to ask you for number of seconds. Then once you get number of seconds, so you can see my variable name now, I'm using underscore to join them as according to the rule. So number of minutes now will now be total seconds supplied because 60 seconds make 1 minute. So we get the floor division or the integer division by 60. So it gives us the number of minutes, and the wrapped seconds will now be total seconds divided by 60. So the remainder, after all the full number of 60s are gone, then we have that remainder, and then we can print the number of minutes like we did before, print the number of wrapped seconds, and we have total seconds equal to number of minutes, and wrapped seconds. So if you run this now, it's going to ask you type in number of seconds. Let me say 2000 seconds, okay? And press enter. So what happens? So 2000 seconds means we have, so number of minutes will be 33, right? Then wrapped seconds. So 33 goes there. 60 goes in 2033 times, and we have 20 seconds left. So it means that 2000 seconds is equal to 33 minutes and 20 seconds. So, that's the beauty of, so you may be wondering, why do we need floor division and modulo division? So you can see, you have seen a very nice case. Or if you are working with number bases, I think this can also be very useful in that situation, in counting, in timing, and everything. So in conclusion, arithmetic operations in Python are powerful, flexible, and intuitive. By combining basic operators with Python's rich standard library like the math module, you can perform a wide range of mathematical computations from simple addition to complex scientific calculations. All right, so that's it about arithmetic operations in Python. So you can see that it's really useful. So if you get to do some of these things, you want to check this out and try your hands on them and enjoy. So that's the end of this video. Tell me how helpful this has been for you. Let me hear that in the comment section, either on Facebook or on YouTube. Don't forget, this code sheets are available if you follow the Google Drive link in the comments in the description on YouTube, and of course on Facebook. So you can download and follow step by step, follow hands-on like this. And of course, you don't need to install anything. Just open Google Colab if you have a Gmail account, and then upload the file and start, practicing. Then you can create new cells and practice whatever you've learned. That's the way to learn these things, because I've learned that you don't learn coding by coding, you learn coding by coding. You don't learn coding by just by reading coding or by just watching some videos, but practicalize as you watch, So that's the end of this. Let me know how helpful this is for you. And if there's something you like on the trial, feel free to let me know. If you have subscribed already, thank you so much. If you haven't subscribed, of course, you are missing out already. So go ahead, subscribe, hit the notification bell, so that you can always get alerted each time a new video is released. You can become a member of my channel also. That will give you some special privileges, like having PDF notes of my math, of the math topics I've taught so far, based on request, and then we can have one-on-one interaction depending on your level of membership. All right. So ultimately, don't forget to like, share, comment, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.